Here the first MCQ before you. I'm going to read that one. Be careful while reading this one and observe the options given below. In an ideal gas, the molecule possesses option A. Here, in an ideal gas, the molecule possesses what? Number A option. Only kinetic energy. B. Both kinetic energy and potential energy. Number C. Only potential energy. Number D. Neither kinetic energy nor potential energy. See, the option we are going to choose one of that one. That is, before that one, keenly observe the postulates of kinetic theory of gases. Molecules of the gases, when they are packed inside the container, they are randomly moving in all possible directions. This is one of that option. But what happens when they are collide with each other? They are continuously in a random motion. That is, we know that it is a Brownian kind of motion. Now they collide with each other. They never loses their kinetic energy. They never loses their kinetic energy. Here, molecules of the gases never loses their kinetic energy. They never loses their kinetic energy. Reason is this one, because they are perfectly elastic. They are perfectly elastic in nature. Perfectly elastic in nature. So that's why they are elastic in nature, and that's why kinetic energy is never be converted into potential energy. That means total energy, we know it is kinetic energy plus potential energy. So what about this potential energy? Kinetic energy never be converted into potential energy. That's why total energy is nothing but your kinetic energy. That means only kinetic energy is the option. That is A. Only kinetic energy. Let us read out the second MCQ before starting it. Here it is, the second MCQ. The mean free path lambda of a molecule, it is given by number A option, whole under root of 2 upon pi into n into d square. B option, 1 upon pi into n into d square. C option, 1 upon under root of 2 into pi into n into d square. And D option, 1 upon under root of 2 pi n into d. Means these are the options. Let us start with this. Now we have the second objective before you. Here it is, the second MCQ. The diagram is before you. Let us understand this one. Somewhat typical, so I will explain that one at last in Hindi also. But here let us understand this one. Let us consider the container inside that one. Yet length of this or height of this cylinder it is, or container it is L. And let the radius of this one is a diameter, or CV radius of this one is a D. Seems to be considered the number of molecules are present inside that one. And they are randomly moving inside the container, exerting one sort of pressure on the walls of the container, even if they are collide with each other. When they follow some sort of random path, they collide with each other, just like this. The single molecule is having the we say diameter is equal to D, and here it is the distance between these two is also, if when they are colliding with each other, the distance between their centers is equal to D. Seems to be molecules are randomly moving inside the container from one place to other place along this length within a given time t. Let delta t is a small interval of time. Small interval of time. So L is the length of that path. So number of number of collision it will take place during this. Number of collisions it will take place during a time delta t. It is given by, see, number of collision in time delta t. It is given by how much? That is n into v into pi into d square into, here it is pi d square, actually it is concerned to the area, into v into dt. How it comes? That is quite simple. We know that length is equal to, or velocity is equal to displacement upon time. We know very well. This way I want to know that how this equation comes. Actually n means what? The number of collision in time t, in time delta t. So I need to consider n is the number of, we say, collisions in time delta t. V is equal to displacement upon time, that is small interval of time. We know that displacement is a d and time is a delta t. So this displacement or length, in short, this length is equal to v into delta t, and we know that it is divided by volume, but we know that volume is equal to area into length, and this area cross section it is given by pi d square into length. Already we have calculated the length, that is v into delta t, and we know that n by v, if n by v into v is nothing but number of collisions in time delta t. So n by v into pi d square, instead of this v I am going to write this v, pi d square into v into delta t is equal to this much. This is our answer. Now this is the equation we have already obtained, but we are going to aim to calculate lambda, that is question mark, that is mean free path. Among that 4 questions I am going to obtain this. So the option is before you here. Now I am going to take n by v into pi d square, v into delta t is the number of collisions in time delta t. So I need to obtain now the value, that is lambda. So how to get that? For that one I have the formula, lambda is equal to the path travel in time delta t divided by number of collision in time delta t. So this gives us idea about the mean free path. So I am going to take here lambda is equal to path travel in time delta t upon number of collisions in time delta t. How much is the path it will travel? That is equal to the length. But we know that length already we have calculated. Where exactly the length? Here it is. The length of the path is how much? V into delta t. So here it is divided by number of collisions. Here it is n by v into pi into d square into v into delta t. But this is nothing but your, we say, a relative, because I need to consider the molecule is in motion. So instead of writing that, one more step I will increase. When molecule is in motion, molecules are in motion. Molecules are in motion, then its relative V into delta T is equal to N by V into pi d square into V, that is relative, because with respect to the other motion of that molecule I need to consider. But we know that relative velocity is equal to under root of 2 into V average velocity. So this is get converted into average velocity. So this is the average velocity and this is relative velocity during the collision. So lambda is equal to V average. Here instead of writing that, I am going to write it small. V average into delta T upon N by V into pi d square into V average into delta T. So this is get cancelled. Okay, this is get cancelled. And what about this under root of 2? It is, we are going to write here under root of 2, because under root of 2 into V average. Instead of that one, I am going to write under root of 2 into V average into delta T. So lambda, it is equal to 1 divided by under root of 2 into pi d square N by V. But number of molecules per unit volume, I can write it as a N. So final answer for the lambda, it is equal to 1 upon under root of 2 into pi d square into N. So which option it is correct? That option I am going to choose. That option is C option. C option, that is 1 upon under root of 2 into pi d square N. This is the correct option for that one. Now in Hindi I will explain this one. क्या होता है जब मॉलिक्यूल्स हम कंसीडर करते हैं तो नंबर ऑफ मॉलिक्यूल्स एक कंटेनर में लेते हैं तो उनका मोशन रैंडम रहता है, तो वो ऑल पॉसिबल डायरेक्शन में मूव हो सकते हैं. जैसे कि अर्लियर वीडियोस में हमने वो जो भी है वो ग्राफिकल व्यू में हमने देखा है या फिर एनिमेशन में देख चुके हैं हम. ये रैंडम मोशन में है तो एक दूसरे से ये टकराएंगे जरूर, इनमें कोलिजन होगा. तो वो कोलिजन होगा तो दोनों में का डिस्टेंस कितना रहेगा? एक्चुअली मॉलिक्यूल का डायमीटर डी कंसिडर करके चलेंगे और ये मॉलिक्यूल में का दोनों का डिस्टेंस जो है वो डिस्टेंस बिटवीन दीज टू, ये रेडियस और ये रेडियस मिलके कितना हो गया? एक डायमीटर हो गया. चलो हम ऐसा कंसिडर करते हैं कि एक कंटेनर है जिसमें ये मॉलिक्यूल्स है रैंडमली मूव कर रहे हैं. तो नंबर ऑफ कितने कोलिजन्स होने चाहिए एक टाइम टी इंटरवल में, छोटे से टाइम इंटरवल में? तो वो कितने रहने चाहिए? एन बाई वी इंटू पाई डी स्क्वायर वी इंटू डी टी. सर ये इक्वेशन आया कहाँ से? ये देखिए ये इक्वेशन ऐसा है. हमको मालूम है कि वेलोसिटी कभी भी हम लिखते समय एरिया इंटू लेंथ लिखते हैं, एरिया ऑफ क्रॉस सेक्शन इंटू लेंथ. तो इसका लेंथ हमको मालूम है, एरिया ऑफ क्रॉस सेक्शन भी मालूम है, सर्कल आ जाएगा एरिया ऑफ क्रॉस सेक्शन, यानी ये पाई डी स्क्वायर, क्योंकि इसका रेडियस कितना है? डी स्क्वायर, पाई डी स्क्वायर. ये आ गया आपका एरिया. देखिए हम अंडरलाइन करते जा रही हैं एरिया, ये देखिए पाई डी स्क्वायर. और इसकी लेंथ हम कैलकुलेट करेंगे. लेंथ कैसा निकालेंगे? देखिए जो भी इसकी वेलोसिटी है वो वेलोसिटी कितनी है? डिस्प्लेसमेंट अपॉन टाइम हम लिख देंगे. जो भी डिस्प्लेसमेंट हो लेंथ के फॉर्मेट में रहेगा, तो ये लेंथ रहा. और टाइम इंटरवल डेल्टा टी, क्योंकि हर एक कोलिजन के बीच में जो भी टाइम इंटरवल होता है बहुत ही स्मॉल इंटरवल होता है, तो हम यहाँ v इज इक्वल टू एल इंटू डेल्टा टी लिखेंगे. तो लेंथ है वो है वेलोसिटी इंटू डेल्टा टी. ये जो लेंथ है हम यहाँ सब्स्टिट्यूट कर रहे हैं. अब मिल गया हमको वॉल्यूम. लेकिन जब भी हम नंबर ऑफ कोलिजन एन बाई वी इंटू वी, तो ये v की कीमत हम यहाँ से लिख देंगे और ये आ गया हमारा नंबर ऑफ कोलिजन इन टाइम डेल्टा टी. चलो ये आ गया नंबर ऑफ कोलिजन. लेकिन हमको निकालना क्या है? हमको निकालना है मीन फ्री पाथ. तो मीन फ्री पाथ के लिए हमारे पास फार्मूला है, द पाथ ट्रैवल इन टाइम डेल्टा टी. जो भी पाथ ये ट्रैवल करेगा कोलिजन में, तो ये डेल्टा टी में ये पाथ हम यहाँ लिखने जा रहे हैं. अच्छा ये मोशन में है, लेकिन जब भी ये कोलिजन हो रहा है तो हम इसको मोशन में नहीं कंसिडर करके चलते हैं। कोलिजन हो चुका है, स्टॉप कर देंगे थोड़ी देर के लिए वॉच। तो यहाँ थोड़ी गौर करने वाली बात है कि हमने यहाँ मोशन स्टॉप कर दिया है, कोलिजन हो चुका है। तो नंबर ऑफ कोलिजन हमको एट अ टाइम कोलिजन कितने हैं वो निकालना है डेल्टा टी टाइम में। तो ये हम निकाल चुके हैं गिवन वॉल्यूम के बीच में, तो यहाँ रख देंगे। रखने के बाद यहाँ मॉलिक्यूल स्टॉप है और यहाँ मॉलिक्यूल मोशन में है, तो उसकी एक एवरेज वेलोसिटी रहती है, हम उसको एवरेज वेलोसिटी रखेंगे। लेकिन ये कब लिखेंगे, पहले तो फॉर्मूला लिख देंगे कि ये देखिए पाथ ट्रैवल इन टाइम डेल्टा टी कितना है, पाथ ट्रैवल लेंथ कितना सर, तो लेंथ कितना है हम कैलकुलेट कर चुके हैं v इंटू डेल्टा टी, तो लिख दो यहाँ। तो इसके बाद ये नंबर ऑफ कोलिजन्स इन टाइम डेल्टा टी, ये नंबर ऑफ कोलिजन्स है वो कितने हो गए, n बाई वी इंटू पाई इंटू डी स्क्वायर इंटू वी इंटू डेल्टा टी। अब थोड़ा सोचा जाए कि यहाँ हमने जो ली थी एवरेज वेलोसिटी नहीं ली थी, ये रिलेटिव वेलोसिटी ली थी। अब व्हेन हम कंसिडर करेंगे कि मॉलिक्यूल मोशन में है, मॉलिक्यूल जब मोशन में है तो ये रिलेटिव वेलोसिटी हो गई, ये एवरेज वेलोसिटी हो गई। अब हम लिखेंगे कि रिलेटिव वेलोसिटी इज इक्वल टू अंडर रूट ऑफ 2 इंटू एवरेज वेलोसिटी, ये फॉर्मूला है अपने पास। तो रिलेटिव वेलोसिटी निकालने के लिए अंडर रूट ऑफ 2 इंटू एवरेज वेलोसिटी हम यहाँ सब्स्टिट्यूट कर देंगे ये रिलेटिव वेलोसिटी के बीच में, जैसे कि हमने अंडर रूट ऑफ 2 इंटू वी एवरेज वेलोसिटी जैसे कि वैसी, और यहाँ इंटू डेल्टा टी। तो जब भी हम ये एवरेज वेलोसिटी इंटू डेल्टा टी कैंसिल कर देंगे, हमारे पास आंसर आ जाएगा कि मीन फ्री पाथ ऑफ ए मॉलिक्यूल व्हेन इट इज इन कंटिन्यूअस मोशन फ्रॉम वन साइड टू टू साइड ट्रैवलिंग अ डिस्टेंस लेंथ and then it is having the mean free path is equal to 1 upon under root of 2 into pi d square n upon v। तो ये नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम को हम n कंसिडर करेंगे, तो हम यहाँ n लिख दिया है। तो यहाँ देखिए लैम्डा इज इक्वल टू 1 अपॉन अंडर रूट ऑफ 2 इंटू पाई डी स्क्वायर n, ये रहा आपका आंसर जो ऑप्शन में ढूंढेंगे कि ये आंसर है क्या, हाँ है, सी ऑप्शन है 1 अपॉन अंडर रूट ऑफ 2 पाई डी स्क्वायर n, ये रहा उसका जवाब। उसके बाद नेक्स्ट ऑब्जेक्टिव हम देखेंगे। वी हैव द थर्ड MCQ बिफोर यू, लेट अस रीड दिस वन। इफ द प्रेशर ऑफ एन आइडियल गैस इज decreased by 10%, if the pressure of an ideal gas is decreased by 10% isothermally, then its volume will how much? Is the volume of that one option A decrease by 9%, B increase by 9%, C decrease by 10%, D increase by 11.11%. See here it is given, if the pressure of an ideal gas is decreased by 10% isothermally, the condition isothermally when it is proved when the PV is equal to constant. So I am going to apply Boyle's law. So if the pressure into volume is equal to constant at constant temperature, seems to be that isothermal condition. So here I need to consider the pressure is decreased by, it is a which option, that is third MCQ. So in that third MCQ here, if the pressure of an ideal gas is decreased by 10%, if initial pressure is P1, so P2 is equal to, it is decreased by how much percent? 10% of P1. 10% of P1 instead of percent I am going to write here, that is 10 by 100 into P1. So how much it will be? Let us calculate this P2. P2 is equal to 100 P1 minus, here it is 10 P1 upon 100 upon 100. It comes out to be here 100 P1 minus 10 P1, that means it is a 90 P1 upon 100. Instead of that one 0 it will get cancelled, only 9 by 10 P1 I am going to write. That P2 is equal to 9 by 10 P1, or that means I am going to write this as a P2 upon P1. P2 upon P1 is equal to 9 upon 10. Now using Boyle's law, I am going to write P1 V1 is equal to P2 V2, or either I am going to write this sentence, that is PV is equal to constant. PV is equal to constant. Here it is the Boyle's law before you. So here I am going to write V1 upon V2 is equal to P2 upon P1. Check it out. V1, V2, P1. So already we have calculated this value, which is equal to 9 by 10. That means V1 upon V2 is equal to 9 by 10. But this is not the expected answer. We need to calculate in percent. So we know that percent. See once again, what is the requirement? Then its volume will be percent volume decrease. Volume decrease. It is given by in percent increase. That is, we can write delta V upon V into 100 into 100. That means I am going to write this equation here instead of writing there. In percent, volume decrease in the percentage of that volume, it is given by. Here instead of writing that one, I am going to write the difference between these two. That means V2 minus V1, that means delta V. We know very well it is nothing but your delta V. So this is your delta V. I am going to substitute this value. V2 minus V1 upon initial volume V1, it is equal to or into 100. We need to calculate, and which is given by, as I am going to substitute question mark, or we can term it as X, and this we are need to calculate this X value. So V2 upon V1, I am going to write V2 upon V1 minus V1 upon V1. It is into 100 into 100 into 100 is equal to X. So V2 minus V1 minus 1, okay, into 100 is equal to X. So X is equal to V2 upon V1 is how much? 10 by 9. 10 by 9. So here it is 10 by 9 minus 1 into 100 is how much? That is 10 minus 9 upon 9 into 100. That means 100 upon 9. So the answer it will be, the comes out to be, answer is 11.11. That means 11.11 in percent. Obviously it is in percent. That means whatever the answer it is always in percent. So I am going to write this in percent. Here it is also in percent. So expected answer is in percent. So which option it is correct? The option here I am going to write the option, that is option D, it is correct. That is 11.11%. This is your answer. Here it is the fourth MCQ before you. Let us read that one. Here, if A means coefficient of absorption, A is equal to 0.72 and R is equal to 0.24. Coefficient of reflection R, and then value of T, that is coefficient of transmission, is A 0.02, 0.04, B, that is 0.04, C 0.4, D 0.2. We'll have to choose the correct option. Let us solve this one. Here, fourth one, A, it is given how much? A means the coefficient of absorption, whose value it is given 0.72. It don't have any unit because it is a ratio of similar quantity. We know very well. You have studied. So R, coefficient of reflection, it is given by 0.24, and we need to calculate the T value, that is coefficient of transmission. And here, which is that value? Let us calculate that. We know the relation, that is coefficient of absorption plus coefficient of reflection plus coefficient of transmission is equal to 1. We know the relation between these three. Already we told the trick also, R is equal to 1. A plus R plus T is equal to 1. So let us start with this. We know very well, we know the addition, that is 0.72 plus 0.24 plus T is equal to 0. Sorry, here it is 1. I will make it 0, 1. So T is equal to, addition of these two, come on fast, 0. Here it is 6, means 6 means 1 minus, what are the other terms? It is 0.96, and here 1.00 minus 0.96. I know you are not in the first division, so first class. That means here the answer is 0.04. So coefficient of transmission, it is 0.04. Don't have unit because it is a ratio of similar quantity. This is the answer before you. Which option it is correct? B option it is correct. So B option, that is 0.04, it is correct one. Let us take the fifth MCQ before you. The ratio of emissive power of a perfectly black body at 1327 degrees Celsius and 527 degrees Celsius is, once again, the ratio of emissive power. Here we need to calculate that. Let us see. The first option 4:1, B option 16:1, next option C, that is 2:1, and D option 8:1. Let us solve this one. These are very simple. How? Let us start. Here we know very well what it is given. The ratio of emissive power we need to calculate. So emissive power, it is denoted by the symbol E. So E1 upon E2, for the two different temperatures I need to calculate. And we know very well T1 is how much? T1 is equal to, how much it is? Firstly 1327, 1227 plus 273. We need to convert this degree Celsius into degree Kelvin. So very simple, it is 1327 plus 273. It is 0. Once again 0. Here it is 6, 1. So 1600 Kelvin. Okay. Next is T2. That is how much? It is 527 degrees Celsius. 527 plus 273. It is equal to how much? 7 plus 3, 0. Now 7 plus 2 plus 1, 9. Once again it is 0. So 5 plus 2, 7 plus carry 1, 8. That means it is 8 Kelvin, 800 Kelvin. So here it is T1, here it is T2. So we know very well, using Stephen's law, we know very well that E is equal to some sigma into T raised to power 4 for black body. For black body. We already studied, if it is not body, just we are going to multiply by small e for the ordinary body. But for the black body, it is E is equal to sigma into T raised to power 4. So this is the general formula. I need to substitute. E1 is equal to sigma constant, T1 raised to power 4. This is equation number 1. And E2 is equal to sigma into T2 raised to power 4. This is equation number 2. Now dividing these two equations, that is E1 upon E2 is equal to sigma into how much? 1600 raised to power 4 upon sigma into 800 raised to power 4. So I'm going to take here. Here even upon E2 is equal to this sigma. Sigma get cancelled. So I'm going to write this 1600 divided by 800 whole raised to power 4. This 2020 get cancelled. It is 2 raised to power 4. Means 2 raised to power 4 means how much? 2 into 2 into 2 into 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. Means the answer is 16 as to 1. Because nothing, it is below written means it is 1. So even upon E2 or this even upon E2, even as to E2 is equal to 16 as to 1. This is your answer. And which option it is correct? That I will choose. That option is B. That is 16 as to 1. This is your answer.